8m, and then I'm going to minus the 3m, right? So 8m minus 3m is, and that equals to 2. Divide, m equals 2. 2/5. And now how do I figure out k? Because that's the other part that I want. Put the 2/5 in there, right? Now I get this guy, and the system goes full circle. So k is equal to 4 times 2 over 5. So that equals what? 8 over 5. So if I were to get those two numbers and plug them in up there and do this whole test again, it would work out. It would be differentiable and it would be continuous. Those are the specific numbers that I need to have to force it to be both. Understand? It's not too hard, right? The same idea, except now you're working with letters, right? Try one more? Yeah. You can't take any more. I think we can do one more, right? Yeah, we got enough time. Alright, so let's look at this bad boy here. For what values of a and b will the function below be differentiable at x equals 1? Okay, so in order for it to be differentiable, it first must be continuous. Right? And if I want it to be continuous, what has to be true? Must be defined. Is it defined? Yes. Alright, so we can kind of skip that step. We can jump straight to the second one, which is that the limit of the function as we approach 1 from either side have to be equal to the other limit. So I'm kind of like writing the formula, Elia, so I could know what I'm looking for and put that underneath. Okay? So what would be the limit from the left of 1? I'm putting in the 1 for what letter? X. So put the 1 in only for the x's. So 1 squared times 3a, 3a. 1 times 2b, or not 2b, plus what? You got it?
Yeah.
It's okay. I just try to come up with this stuff on the fly, you know. How about the limit from the right? I gotta feed off the energy of the crowd. So 1 to the 4th? 1 times a is just a, right? 1 to the 2nd is 1 times 4b. 4b, 1 times 3 is 3. Okay. Can I do anything to this equation? Move the stuff around, right? So we can combine like terms? So let's do it. So minus the a and add the 4b. So that'll give me 3a minus 1a is 2a plus 6b plus 1 equals negative 3. And I don't like this 1 here, so I'm going to minus it. So I have 2a plus 6b equals negative 4. Ah, man, another equation with 2 variables. Why do you do that to me? I can't take this anymore. Just kidding. So that means we need another equation, right? And we're going to get the other equation by the other part of the 2-part process, right? So what else has to be true? Very good. So if f of x is differentiable at x equals 1, what must be true? The limit of the derivatives as we approach 1 have to equal each other. It's crazy stuff, man. We're barely in the first semester and look at all the things we have to remember. We haven't even touched integration. The antiderivative. Alright, so in order to do this, we first need what, Vanessa? The derivative. Alright, so let's get the derivative of this guy up here. We can do that. We're masters at derivative. What's the derivative of the top? 2 times 3, 6a x, right? Plus 2b, and we're done, right? The bottom, 4 times a, that's 4a x to the third. 2 times 4, 8bx minus 3. Beautiful, okay? Don't freak out with those letters. Remember that they're just some constants, some numbers. So can we find the limits now? Remember, Gabriel, that we're plugging in that number only for the in the derivative, but only for the x. Okay, so let's do the top one. So put in the 1 there. So that gives me what? 6a plus 2b equals, plug in the 1 in the bottom one. 1 to the third is 1 times 4a. 4a. 1 times 8b. 8b minus 3. What do you think I'm going to do to this one? Move stuff around, right? Minus 4a plus 8b. Minus 4a plus 8b. That's going to give me 2a plus 10b equals? Awesome. So do I have my two equations? Can I put them together in order to work it out? How do you want to solve this system? Because remember, we learned multiple ways of solving systems. Can we do elimination? I don't know. Let's see. Let's put them together first. Okay? So I'm going to write 2a plus 6b equals negative 4. And then I'm going to have the other one underneath it. 2a plus 10b equals negative 3. Do you remember problems that look like that in Algebra 2? Ooh. You remember this? And then, how do I solve this? RF? We could do RF, right, with matrices? Remember we would make this big matrix, and then we put RF in the front? And then bam, we got our answer?
Bam.
Oh, yeah. Remember that? Remember we would say, don't F it, RF it. Yeah? You never did RF? Oh my God. So then what did you do?
And you add zeros to the missing.
I remember doing that.
Yeah, I remember we would put zeros if this was missing, if it was just 2a. If it was like that, I wouldn't do it matrix. I'd just find a and plug it in. We used the matrix when we had more than 2 equations, right? Most of the time with 2 equations, we would just do it by hand. So yes, one of the methods was elimination, right? So that was where you would multiply one of the equations by something to get one of the variables to cancel out. So what would be a variable to get rid of?
2a.
The 2, right? All I would have to do is multiply one of these by a negative, right? And then that would get it to switch in order to cancel out. So that would make it negative 2a minus 6b equals 8. Remember, the negative goes to every. You can do whatever you want to a problem as long as you do it to everything in the problem. Just kidding. I was looking at the 2. You're right, it's 4. I'm human, guys, even though I seem superhuman at times. Don't forget.
Yeah, that's Superman 1Z.
And now we combine them. Yes, remember my Superman? So this cancels out. 10 minus 6 is what?
Super 440.
4. Negative 3 plus 4? 1. Divide, so b equals 1. And now how do I get a? Plug it in, whichever one, right? Where do you want me to plug it into? The first one over here? Okay. So let's plug it in. So we're going to have 2a plus 6 times 1/4 equals negative 4. So that gives me 2a plus 6 over 4 is equal to negative 4. Right? Now what do I have to do? Minus 6 over 4. So I have 2a equals what? What's my common denominator going to be here? So times 4, right? Times 4. So that gives me negative 16 minus 6 over 4. What's negative 16 minus 6? Negative 22. Okay. So now I have 2a is equal to negative 22 over 4, which is negative 11 over 2. Is that okay? And then we have to divide by what? That means these two guys multiply, so a ends up being negative 11 over. This is all algebra, right? It was calculus up until right there. That was calculus. And now it became algebra all over again. Cool? What's up, Shermanator? How's BC?
You guys have been back like what, a month and a half now?
You guys already done or no?
What do you mean? It seemed like the worksheets.
Cool, man. Just go to, what's it called? The
What is it? Where?
Khan Academy.
It's lit.
Khan Academy, man. Put some video. I'm making excuses, man.
You know when he's gonna be back?
I have no idea.
You're saying that Mr. Lucas went to go save him.
Yeah, maybe.
Alright.
Bye. Alright, so are we good? Yes? Awesome. Okay, so that's it for the notes. Your assignment is given to you. There's going to be some problems in there that are kind of not related to what we did. There's just going to be like some random problems in there, okay, regarding not differentiability, but there are some that are very related to the notes. So don't freak out if there's a question in there that doesn't match the examples we did in the notes. Okay, it's just kind of like a mixture of problems from the things we've done in the past, just to see if we can put it all together. Sounds good? Alright, so go ahead and give it a try. And if you need help, I'll be here. And on the back, I did make a mistake right here. Okay, I put D 2 times, so forgive me. Just scratch out this one right here, because I had already asked about the largest derivative. Okay, scratch out the first D. Pretty good? Alright, so use the rest of the time to work on that. And while you do that, I'll print out your progress reports.